Okay, continuing on in our video series for Civil 3D basic bridge design. In this video we're going to create a roadway profile and set the finished grade profile for our roadway. In the last video we created a horizontal alignment that generally followed the center line of the existing roadway here, and again we have our bridge right in the middle of it. It's a little bit off section, but that was kind of the choice as far as the design, following the center line of the existing road. But what we need to do now is create a profile view in which we can establish our finished grade profile. To do that, we need to first have an alignment, which we do have, and we need to have a surface that it can sample along this alignment to create a profile. So the first thing we need to do, on the Home tab here under the Create Design section, we'll click on Profile, and we want to create a surface profile. And basically what we're doing here is we are going to create a specific profile, which is the existing grade or our existing surface along the alignment. So we're going to select alignment. There's the only one we have in here, so that's what we have, and we're going to select this surface, and then we need to add down here, and it's going to sample it based on our alignment. Now this is the start and the end of our existing alignment. We could sample a shorter section, but we want it for the entirety of the alignment. Couple things we want to do, just personal preferences. We want to change the style here, and I want this to be CTC EG centerline. Now a lot of these are based on our own specific styles, and so you can set those to however you want, or create these within AutoCAD. But it's good to have a style that is existing ground, to differentiate it from a finished ground surface. So we hit OK. And now what we want to do is draw this in profile view. So we click here. And now it comes up with the Create Profile View dialog box. So again, we still have our alignment. We want to keep profile view names not really that important. We want our profile view style to be ODOT full grid. Again, these are internal styles we have created, but there's a lot of good options here. And profile view layer, it doesn't really matter. We can leave it on 0 because this won't be a big deal. We don't need to turn this on and off necessarily. So we'll go to next. We want our station range to stay the same for the full length. Our profile view height, we want it to survey the full range that it's finding along the alignment. And then here, we come in here, and then this is how the profile is going to be displayed. So we set the style in the last one, but one thing I want to do is basically turn labels off. I don't want it to label the existing ground. I just want to see the existing ground. I don't need it to show me every curve and tangent and all those things. So we're going to hit OK. Next, we don't want any bands yet. You can go ahead and set those, but just based on personal preference, go ahead and set no bands right now. And we'll wait till we have our finished grade set before we do that, because we don't have, essentially the bands will be along the bottom. It'll tell at each station an elevation for the finished grade and the existing ground. But until we have our finished grade, it's easier to just not mess with it. We'll hit next, and we don't need any of this right now, because we don't have anything there. So now we're going to create a profile view. Normally you just kind of want to stick it off to the side that's far enough away from here that it wouldn't be in the same viewport, for instance, for your plotting. If your roadway was going horizontally, it's nice sometimes to be able to set your profile to be directly underneath that, and you can always use the viewports to kind of set that up. But otherwise, we're just going to kind of put it out here in space. So you can see now this is our alignment. We have our stationing going from south to north, come along the roadway, go through the creek, and then back up the hill. So now we see our roadway profile, and this line here is our existing grade. And so you can see when we clicked on it, now it has a property. It is a profile. It is a set profile with the style e.g. centerline. Now we can change the name here, and we could call this Iowa 06 e.g. centerline, and that way we know. But this is our profile view, and so it's got stationing along the bottom, and we've got elevations here. I will note, and this is based on our specific styling, if we measured MEA the distance between station 10 and station 11, it's 100 feet, as it should be horizontally. But you'll note these elevations are exaggerated, and they're actually exaggerated tenfold, and so that's 50 feet between 895 and 900. So we have a 1 to 10 vertical exaggeration on our profile. It's not something you have to do, but especially on a smaller project, it helps to see kind of what's going on in creating your profiles. So now that that's done, we're just going to save real quick. And as I mentioned earlier, under our alignments, now for this Iowa centerline alignment, we have a profile that we've created and a profile view. Now we didn't name this profile view. It's not that important. If you want to do that, that's personal preference. But now we have our profile, and we have our existing grade centerline profile. So the next thing we want to do, so this really doesn't get us anywhere. It's great to see this information, but we haven't advanced our design any. What we need to do for design's purposes is to set a finish grade profile for the center line for which we will design the road from. Now for any bridge or any creek crossing, a lot of this is going to be determined based on your hydraulics and hydrology in sizing your bridge. So normally what you would do in the design process is get to this point. You play with the design, you see what your profile looks like, what options do you have, if you need to raise the road up, if you need vertical curves, things like that, and go back and forth. Either you run the hydraulics or talk with your hydrologist to assess what options there are and how you can, what structure you need to put in. But prior to doing any of that, and just for reference, it's good to just lay out a basic profile. Normally the standard is try to match the existing. Most roadways, for the most part, you can follow the center line of the existing roadway, even if it's a full reconstruction or things like that. They're normally fairly close to what you want to keep. For bridge replacements, a lot of times you may have to raise the roadway a little bit to meet hydraulic standards of overtopping and things like that. And for some of these smaller county roads, they may not be actually designed to the county standards or currently meet county standards. So you'll have to upgrade things like vertical curves, like tangents, to meet the standards in your design. So those are some of the things you'll have to fix. So what we want to do now is just throw in a basic roadway profile and be able to illustrate some of the ways to do that. So to create a finished grade profile, what we need to do is go back to our profile drop down up here, and now select Profile Creation Tools. And now it's asking select a profile view to create the profile in. Obviously we have this one, but this will work for multiple. You just click the one you want. And now we have a box that's create a profile. So we do want to name this one. And so it's good to always retain your project information within any of your objects. And so since the other one is EG centerline, I want to name this FG centerline, or finish grade centerline. So profile style, we want to use the O.design profile, and again these are our set internal styles, but you need to set a style. Profile layer, again we can keep this as 0, it's not that big of a thing, but for our finish grade we actually want a full complete label set. We want to see all the information for the vertical curves, see the information for the tangents, etc. And then we do want to select our design criteria. Now you'll note when we created the alignment, it had an option to put a design speed, then to check criteria based design. Here we don't have that option because again the profile is lower in the hierarchy to the center line, the alignment. So the alignment speed that we set dictates the speed for the profile. But we still want the criteria design because that helps us meet the standards for vertical curves and things like that. So we'll keep all that, and now I'm just going to hit OK. So similar to when we created our alignment, almost the exact same dialog box pops up with the same tools. And so, but now this is our profile layout. So we have our lines, our fixed tangent lines, and we have our curves. And then we'll get into, again, our geometry aspects. So what I'm going to do is I'm going to start with just a tangent. Now, sometimes, back up just a bit, sometimes it's good to come in and just draw this roughly with polylines to kind of help guide what you want. So say, and this is very typical in a lot of county roads, you see a little bit of a dip and a rise before you get to a crossing, a bridge crossing, and a little dip. Most of the times you're going to want to navigate across that, smooth some things out. Or let's say your hydrologist told you we need to set a certain elevation for this. So let's just use about in here for reference. So we're going to come up, I like to do it this way. So from 920, let's come up, let's just say 2.5 feet. So we'll type 25 because again this is vertically exaggerated. So that comes right about to the top there. So I'm going to draw that line across there. And so we know this is going to be flat across the top. And let's just say we're going to put a bridge structure here, or any box structure, but we want it to be flat right across the top. We'll follow the general profile grade coming down the slopes, but at a certain point we want this to be flat. So I'm going to use the tangent, and I'm just going to start, maybe we don't need to start at the very beginning, we can start it a little bit further down here. But let's say we want to establish it here, and I want that to run to about here. Now you click, and again this is where it's important to right click in that specific command. Now go back to the tangent and create a new section. We're going to come from that last point, and maybe we'll come just across here, right click, and then now we want to create maybe just a couple more. And right now we're just going to stick with with lines. And obviously we're not going to keep that constant, but we're going to come up, say, to here. And that's our basic profile. So now we have a single feature here. That's our profile. And if we go to the screen button, profile grid view, it actually will show us the stationing for the point of vertical intercept and the elevations, the grades in and out, grade change, things like this. This will become very useful as we update and as a way to manually kind of update by physically typing in some of these things instead of just dragging grip edits if we want very specific things. So what we need to do here now is work on creating vertical curves. So if we just assume this is going to be the way it is, we probably need a vertical curve between these 2 points. And again, the way to do that, if we have 2 tangents, we can use the free vertical curve, the parabola. Select that as the first entity, select this as the second. Now, when we're designing vertical curves, we have to meet the K standards. So these probably vary between different states for different types of roadways. Again, AutoCAD follows the AASHTO standard, which probably a lot of counties and states will as well. And so that's a good guide, but always double check your county standards. So it says specify a curve length, or we can specify a radius, pass-through distance, or the K value. So I know if I click on K, I know there's a minimum standard for K. Now, it gives you an option here of what it can fit, and if you just hit enter, it automatically creates a curve. Now, obviously that's tiny and doesn't really do much for you. But if we take a look now back here, we have a curve built in. This is the grade in, the grade out, the curve type, sag curve or a crest curve. So it'll tell you right here curve length and the K value. Now it also has a warning, and so now it's telling me I have a violation. So this is very important, and kind of the tricky part of designing vertical curves is you have to meet these K values for different things. There's stopping sight distance, headlight sight distance, passing distance, things like that. On a county road, obviously you're not as concerned with passing distance, but stopping distance, headlight distance are important. So this is just an example. This won't be our final profile. That will take a lot of back and forth. We'll need to work with the hydraulics, things like that, but this is just for reference. So let's try to put a curve in here. So we click those two, and again I'm just going to enter a K value. Let's say I want a K value of 50. And there, now we have a bigger curve. Now we can see if that violated anything. Yep, we're still violating certain things. So I believe the ODOT standard, Oklahoma Department of Transportation standard, is a K of 64 for a sag curve, based on a design speed of 40 miles an hour. So let's try to see if we can fit that in. So we can actually come in, click on that, and we can manually come in here and type in the K value 64. And you can see it automatically adjusted that down there. So we're good on this one, but let's see if we could fit that into our other side. And we actually can. So that's good. Now, when looking at this profile, just some things to think about. Now, it's very easy to just start this wherever you feel like, but you have to generally realize that you're probably violating the grade break distance here. So it's always good to establish one tangent to begin with that follows the existing ground. So what we could actually do is come back, bring this one back here, and you can use your grip edits to drag these around. But I'm actually going to come in and add a PVI, point of vertical intercept, and I'm going to stick it right here. So this generally, it's not exact, but this generally follows pretty much what the existing ground is before we start here. So we could even drag this, a bit further down, something close to that. But let's say right there. So now we have to evaluate this existing ground over here, which is a negative 1.66 grade, and what we have designed here, which is a negative 0.32% grade, and determine whether the difference in those two grades is sufficient to put a vertical curve in, which normally we want that to be less than 0.5% or so. So this is getting a bit much. So we need to put a vertical curve in coming from the existing ground to our slope here. We can try that. We can again use our K of 64, see if that works. That actually works in here. And now here we go. So similarly, we would need to do that on this side coming down this slope. And another consideration, obviously within this design, is general drainage. We have a very low slope of only 0.32 here. Normally we want it to be at least 0.5%, if not 1%, sloping down here. And again, we have this long stretch that's just 0%. So it would probably be better to come further back up in here. We could potentially drag this further back. And sorry, accidentally deleted that. And we can adjust these parameters. So this is part of more the art of creating profiles, working with your hydraulics team and just going back and forth constantly, nitpicking at this, moving things around until you can fit this all in. This may be a situation that we have to come down a little bit more and bring the road back up to pass through the structure. Again, once you determine the exact structure size, then you can make the adjustments to this set profile. But again, this is just the basic overview of how to create a finished grade profile and profile view. So we're going to leave it here, but I do want to point out now that if we assume that this is our final established profile, again, we have our labels for our curves, we have our distances, we have our grades. But again, if you see underneath our centerline alignment, now we have both an existing ground centerline and a finished ground centerline, all within our profile view, but all within this same hierarchy of our alignment. And from this point, now we can continue on in the design process. We have an alignment, we have a profile, and the next thing we can do is create a corridor, which is basically our roadway using these two objects. So that's it for this video, and we'll continue on next time.